Okay, hi everyone. Good evening. Before we start our today's session, vSphere Storage Concept Session 6, let me answer the questions. So let me log into the vCenter server as well. Okay, our vCenter is still connecting. I think vCenter service is taking time to load. In the meantime, let me connect to the ESXi host. Suppose I'm connecting to the host 10.71. I'm just checking the ping status of the host. 192.168.10.71. Okay, host is up. Yeah, host 71 is up now. Yeah, all the hosts are up. Okay, when we log into the 71 ESXi host, I will try to explain the two questions using this single host. The first question is provisioning service. Normally, the provisioning is nothing but anything related to the environment. If you want to set up a new VM or if you want to set up a new server or anything, we consider as a provisioning. Provisioning can be a virtual machine provision or network service provision or storage service provision. Anything the newly we are going to deploy, it is considered as a provisioning service. When comes to the vRelays automation, provisioning service includes the virtual machine creation and also assigning the virtual machine network and assigning the virtual machine storage. These all considered as a provisioning service, and not only compute network storage, even the if you are adding a new firewall setup, that is also provisioning a firewall and provisioning a load balancer. So that is a one of the keyword we'll use for all the services. Okay.
Okay, sir.
And the second question, how we can add the LUN to ESXi host and vCenter server. So if you want to add the LUN to a ESXi host, just log into the ESXi host using the vSphere host client. When we log into the vSphere host client, you can go to the storage section. And here we can have a option for new data store. In our previous lab, we created a vSAN. So even the storage type is showing as virtual SAN. If you want to add a LUN here, in our storage terminology, we call it as LUN, logical unit number. When comes to the VMware ESX environment, just select the new data store. We have a multiple options. The first option is create a new VMFS data store, because our ESX host supported only for the four types of file system format. The main is virtual machine file system, and another file system type is network file system. All the LUNs are configured within a VMFS only. And if you want to extend the existing VMFS data store. Like let's say my VMFS data store size is 1 TB. If I plan to increase from 1 TB to 2 TB or 1.5 TB, during that scenario, we'll use second option. And also expanding the existing data store, we can use this third option. And the second one is like adding the extent only. It's like adding a new VMFS data store. And the very fresh VMFS data store relevant option is first option. So when I click next, we can see the option to select the device. Let's say data store name, we can keep any of the name, and the name can be, we should follow the environment real-time naming convention. And when we assign the name, it will automatically discover whatever the FCSAN is connected in our network, it will be discovered here. At present, we do not have the FCSAN network here, so that's why it is showing us no devices with free space. Normally, if before adding the FCSAN network here, what the recommendation is, we can go to the adapters tab. Every FC card connect with a VMHP only, virtual machine host bus adapter. We have to do the rescan here. When we click on rescan, in our recent task, it says rescan HPA is complete. After the rescan, go to the data store, click on new data store. You can try to add the new VMFS data store. This is the procedure to add the FCSAN data store or any of the data store, either FCSAN, iSCSI SAN or FCOE SAN, any LUN. If you want to add it on the ESX level, this is a procedure. I repeat, the first step is a rescan. Once the rescan is completed, then come to the data store tab and add this procedure in a single host level. Suppose in the vCenter level, log into the vCenter. It seems the service starting is taking time. In the meantime, let me try the other vCenter. Okay, other vCenter is up. Okay, when we log into the vCenter server, we log in vCenter server using vSphere client only. Currently, we have 3 SXI hosts. If you want to add a LUN on the vCenter level, here the procedure is the same like ESXi host. First, we can select the specific ESXi host, or you can select the specific cluster, go to the data store tab. Under data store tab, here the currently the existing data store is VMFS data store. If you want to add a new data store, go to the actions, again select the storage, new data store. But before adding the new data store, same like ESXi host, we have to do the rescan. Rescan is mainly for when I click on the rescan storage, you can clearly see the options. Why we doing the rescan is the scanning for new storage devices and also scanning for new VMFS volumes. Whatever the LUNs are mapped to our ESXi host, all the mapped LUNs, if you want to view from the vCenter level, the initial step should be we need to do the rescan storage. This rescan storage, it will help you to discover your new HBA cards as well as newly assigned LUNs from the storage administrator. The LUN creation and all storage administrator will do, but from the vSphere level, we have to log into vCenter server using vSphere client and go to the data store tab and do the rescan storage first. When you do the rescan, we are doing directly at the cluster level. This rescan will applicable automatically to all the three ESXi hosts. And once the rescan is completed, what we can do is even rescan, if you want to test one more time, again go to actions, storage, rescan storage, and click on OK. When you click on OK, you can see the rescan information from the recent task. In our recent task, there is a rescan VMFS, rescan all HBA, host bus adapters are rescanned completed. Because currently in our lab environment, there is no FCSAN. That's why rescan is completed very fast. But in the real-time scenario, if you really connected to the fiber channel switch, through the fiber channel switch, when you connected to the fiber channel SAN, definitely the rescan may take minimally 1 to 2 minutes time. Once the rescan is completed, again go to the actions, storage, you can choose the new data store. When we select the new data store, see we can see the data store type. Even our virtual SAN, it's not using from new data store level. It's like a grouping at the local hard disk. So vSAN option we cannot see here. We can see only the remaining three data store types. One is virtual machine file system. This virtual machine file system data store we can assign mainly for local hard disk as well as LUN, logical unit number. And logical unit number, it's not only one LUN, we can add multiple VMFS, multiple LUNs we can add. Storage level terminology is LUN. When comes to the ESX level terminology is VMFS data store. Okay. And NFS is for a NFS storage. It's like a file system name, protocol name, both are same, network file system. And the storage we can call it as a NAS storage, network attached storage. And virtual volume, this is the concept we are going to discuss today. VVOL full form is virtual volumes. In short form we call it as VVOL. So create a virtual volumes data store on a storage container. Storage container is nothing but a array of multiple disks, or we can say just a bunch of disks. The disks can be either SATA hard disk, SCSI hard disk, or all flash drives. All storage container connected to a storage provider. Here storage provider is nothing but a whatever the vendor storage we are using, that storage provider. Like HP storage, HP Nimble storage, or you can use Dell storage, you can use IBM, Hitachi. There are so many storage vendors. Any storage vendor is considered as a storage provider. This storage provider's container, using that storage container, you can create a VMFS volume. Okay. So hope I answered the both questions. The second question also, how to add the LUN, we can verify on how to add in ESX level and also in the vCenter level. Is it clear, or if you have any other questions, let me know.
Yes, clear. Thank you.
Yeah, thank you. Okay, let's back to our today's session. Okay. So vSphere storage, within the vSphere storage concepts, we completed until now 5 sessions. Today's is the sixth session. Within the sixth session, we are mainly focusing on virtual volumes architecture and also the home lab. Home lab, in today's session, I will give you the brief introduction for home lab, and the next session, I will show you the actual lab. Okay. And here is the today's agenda. Our agenda is again the same like our previous session. We'll first quickly run through the vSphere storage overview, and then we can verify the customer challenges and what is the solution scope provided by virtual volumes and virtual volume architecture. Within the architecture, we can verify all the components one by one, and also the vSphere virtual volume. vSphere virtual volume is nothing but it's a data store. It contains all the virtual machine objects. And vSphere virtual volume SPBM. SPBM means storage policy based management. This is one of the important concept. I will explain in detail for the SPBM. And virtual volume data store creation. What is the steps required to create a virtual volume data store? We can discuss. And also the virtual vSphere storage real-time scenario. This real-time scenario is not only for virtual volume. I will cover what are all the other storage models available for a FCSAN, iSCSI and NAS. Okay, and because these real-time scenarios will be helpful when you are directly working for any of the projects. Uh, Based on the customer scenarios, we should have a knowledge on storage concepts also. What are all the models of storage are available? That knowledge is required for easy understanding. Okay, and finally, we'll observe the lab. We virtual volumes lab is possible using the simulator, but if you want to do a real lab, we need to buy a original storage. But instead of buying a original storage, we can do the same lab using the virtual volume simulators. Okay, so let's start with the vSphere storage overview. So we are very familiar for this architecture diagram because this is the one, it will give you the complete vSphere storage overview. Let's quickly run through one by one. Let's say the right side, the main point is vSphere supports the following types of data stores. The data stores, type of data stores are virtual machine file system, VMFS, network file system, NFS, virtual SAN, vSAN, and virtual volume, vVols. Within this four file system, VMFS is a file system, NFS is a file system. Number 3 and number 4, vSAN and vVols is considered as a software defined storages. Okay, and ESXi host should be configured with shared access. Why we need to configure with shared access is if you want to use the virtual center, all the features like vMotion, SVMotion, HEA, DRS, in order to use all the features, VMware main condition is all our ESX hosts must store on a shared storage. For to provide the shared storage, you can configure any type of data store. It's a subjected to be customer requirement. Some customers they may use only VMFS, some customers use NFS, some customers use vSAN, and so depends on the customer requires. Some scenarios they may use virtual volumes. Okay, all the scenarios we'll discuss today as well. And let's talk about the architecture view again. Now mainly the virtual disk, we know in our hardware we are installing ESX. On top we created a multiple virtual machine. In this diagram we have a 3 ESX host and it's running with multiple virtual machine. And the data stores, we have a second row data store types, VMFS, NFS, vSAN and vSphere virtual volumes. And we in our previous sessions we observed VMFS can be configured on direct attached storage, fiber channel storage, FCOE, iSCSI. Even the transport protocols also for FCSAN same protocol, fiber channel, and FCOE, fiber channel over Ethernet, iSCSI protocol. But only thing is in our local hard disk we can call it as a local disk only, either SSD, SATA or all fast drive. That's where our virtual machines are backing up. But when comes to the storage environment, the naming convention instead of disk, we call it as a logical unit number. Every LUN have a unique identification name. LUN addressing we discussed in our previous session. Fiber channel LUN addressing. Same way we know the FCOE LUN addressing, iSCSI addressing. But iSCSI SAN addressing is starts with a IQN. Either we can define iSCSI addressing in IQN method, or we can use the IQN alias name, or we can assign a host name or IP address. Anyway, we can use a iSCSI. And comes to the NFS also, the transportation network is only the normal IP based network. That means Ethernet, and the file system is NFS. And when comes to the virtual SAN, we doesn't require any of the external storage. We are configuring only on the direct attached disks. So that's why I highlighted here direct attached. And even in our previous lab, we configured the vSAN using 3 SXI hosts. Each host we assigned a multiple hard drives. Using a multiple local hard disk, we make it a virtual SAN. And virtual SAN, we call it as a virtual SAN cluster only we created. Okay, but when we create vSAN cluster, when we enable the vSAN feature in our cluster level, how we enable in the cluster level? Suppose log into our lab system. See, when I right click the cluster, go to the edit settings, we can see the DRS feature availability. If you want to enable the cluster, we can enable from here. Either you can go for a cluster quick start method to enable a vSAN feature. When I click here in our cluster edit settings, we can see the vSAN option. Okay, so that's why we can use vSAN cluster feature. Okay, the same option I mentioned here, vSAN cluster. So when you enable vSAN in a cluster level, you can able to configure the vSAN data store. Now today's session is here we no need a local hard disk for virtual volumes. For virtual volumes, we need a real sandbox. Same like FCSAN, iSCSI, need a either NAS box. Any original sandbox is required. That is considered as a storage container. Only the naming convention is different. That naming convention is in our previous FCSAN and iSCSI, we configured a LUN, logical unit number. But when comes to the vSphere's volumes, the VMware and storage technology vendors, they removed the complete, they eliminated the LUN concept. There is no LUN concept. The direct raw disks we are going to make as a storage container. But how they are going to make a storage container and all, we'll discuss in the following slides. But there is one scenarios or in the customer scenarios or interviews, they may ask, we already have VMFS storage and NFS storages, but why we still go for a software defined storages? Definitely when we are going for a software defined storages, there is a business use case. The main business use case is, I mentioned in the last point, predefined storage options. When you procure any NAS box or FCSAN, iSCSI, by default, initially the storage box comes with a predefined storage options. Either your storage box can be configured with RAID 1 storage box or RAID 10 storage box or RAID 5 storage box. But when comes to the software defined storage, this is completely software defined, not limited to one RAID level. We can configure a multiple RAID levels. That is nothing but here we can configure a multiple storage policies. In other words, we call it as SPBM, storage policy based management. That concept is comes to only in a software defined storage. So that is the main reason why we prefer to go for a software defined storage. It's a completely customer requirement. If your customer requirement really need multiple RAID configured virtual machine, definitely you can choose either virtual SAN or you can choose virtual volumes. Okay. Now we are going to observe the customer challenges virtual volumes solution scope now. So in our customer environment, there will be some challenges using a traditional storage. So let's talk about the customer have major concerns about storage. I highlighted here three main challenges. The first challenge is storage management is too complex. Obviously, storage management is definitely is taken care by storage administrator. They will take care of the entire storage box, LUN masking, creating the zones, maintaining the fiber channel switches, fiber channel cabling, and all taken care by storage team only. That is their duty. Most of the environment, the complete storage is maintained by storage administrators. But here, the challenges are explained here. Setting up storage require too much time. So we require too much time, and the data operations are LUN centric. It's always the data how we can operate means it's always we are storage administrator used to create the LUN. That LUN when they present it to our ESXi host in our ESXi level, while adding that LUN to ESX level, the terminology we call it as a ESX VMFS data store. But in the back end, that is actually a storage level configured LUN centric only. Okay, and we want virtual machine focused operation. So this is the one of the main customer requirement. Customer may ask to virtual machine focused operation. They don't want LUN centric operation because the LUN centric is nothing but a when you configure your storage box with the LUN RAID 5 configured storage box, all your runs also by default comes with a RAID 5 features only. You cannot use a additional RAID level features. Okay, that is the one challenge in physical storage. Okay, and the second challenge, cost of ownership is too high. Obviously, when you buy a storage box cost is FCSAN cost is very high, and if you go for a medium range cost, iSCSI box, lower level cost, it's a NAS box. But even though when you buy a storage box, it's not enough. We require some additional licenses. We require additional licenses for fiber channel switch, and fiber channel, each port also require a additional license cost. So that's why the cost is too high. Suppose I have a fiber channel switch with 32 ports. We need to buy 32 port license also. So each port is chargeable. But when comes to the normal iSCSI and NAS box, that fiber channel switch cost can saved, but still the storage box cost is same. Okay, and the only challenge in our this fiber channel SAN and iSCSI SAN is we over provision the storage. Over provision means we can create the virtual machine based on our, suppose my storage box overall size is 32 TB. Within the 32 TB, there is a chances of over provisioning. We can configure the data more than 32 TB, but we need to address the data. And also if we configure the entire storage box with RAID 10, RAID 10 minimum requirement is 4 hard disk, and maximum we can create a number of hard disk. But when we create a minimum 4 hard disk for each virtual machine, the data loss will be very high. I mean, the data physical hard disk losses will be very high. So that is nothing but a over provisioned storage, and our storage budget keeps going. Suppose your sandbox already all the disks are fully occupied, we assign the LUNs. In future, there is a new requirement. Customer want to build a additional 50 virtual machine. For additional 50 virtual machine, if you do not have enough storage in your sandbox, the only option is we need to buy a new sandbox. When you buy a new sandbox, again need to set up with the sandbox rack and sandbox cabling, and also we require a fiber channel switches, fiber channel switch port licensing. This and all, always the storage budget is keeps going up. This is the second challenge. And let's talk about the third challenge. Third challenge is SLA. SLA means service level agreement. It's like a normally an agreement between customer and our company. Let's say our company is Hewlett Packard Enterprise, HPE. From HPE, I took another project. Let's say the project name is any project. For example, HPE going to provide a support to the Genpact or Capitaland company. So this company, when HPE going for a any of the project tender, when they own the project, there will be a some SLA agreement. It's like a same like our house agreement. Even when you go for a house registration, either a tenant or permanent house, there will be some registration agreement, right? Similarly, in our company also, when we are going to take up a one project for 5 years project or 10 years project, that project contract information, everything is available in a SLA. That contract is considered as a contract only, but within the contract, one of the key item is SLA. That SLA means service level agreement, an agreement between customer and client. Okay. So these SLAs are too difficult to ensure. Sometimes when we are using a normal traditional storage boxes, there will be some customer SLAs are different types of SLAs. We are unable to meet all the SLAs when using a standard sandboxes. So the same point I elaborated here, SLAs cannot ensure predictable performance, and troubleshooting is very hard. So to address these three challenges, we can use for a virtual volumes. So that's why VVOLs means we can say to address these three challenges. In the right side diagram, if you see the diagram is virtual machine can directly talk to the storage container. So that means there is no in between, there is no LAN concept. But we require still the LAN connection, FC-SAN connection, switches are needed. But the only thing in the virtual volumes is there will be no LAN concept. The entire LAN concept is eliminated. That is only the importance of virtual volumes. And virtual volume, how the virtual machine stored, it's based on the policy only. If you see this diagram, virtual machine, this box refers as a virtual machine, and it's run based on the storage policy. This storage policy normally we maintain like a t-shirt sizes, like a small, medium, large. If your virtual machine is a large VM, you can choose the storage policy as a large VM. So this VM will go and store on a large container data store. And suppose your virtual machine is medium policy. That means the medium size VM, it will store on a medium storage container. Okay. Suppose if you do not have a policy concept, We are using a normal sandbox. In that scenario, we cannot maintain this many policies. Always we should stick with our storage vendor given policy only. That means predefined policy only. One policy only we have to maintain. But when comes to virtual volume concept, it's not limited to one storage policy, one predefined storage policy. We have a facility to create a multiple storage policies. Okay, that is the benefit of virtual volumes. So next slide, we're going to discuss, we can elaborate the virtual volume solution scope. Okay, so the customer challenge, some additional points. The storage operation model transformation. When compared with the traditional storage and virtual volume, the complete transformation is the only key point is in our traditional storage we have LUN concept, but when comes to vVOL, there is no LUN concept. The LUN concept is completely removed. Let's talk about all the points one by one. Let's say in this diagram we have a storage boxes. From the storage we created a virtual machine. That means it's a hardware centric. It's a depend on the our storage hardware. And vendor specific management. Even if you want to manage our traditional sandbox, we require a vendor management tool to connect our sandbox. Same like to maintain our virtual machines, we require a vCenter server management tool. From the vCenter server only we can connect our ESXi host and virtual machines. Similarly, to connect our sandbox, we require a vendor specific management tool. Okay, and only the storage administrators only can manage the storage, and vSphere administrator cannot able to log into storage. We can able to access the LUNs only. We cannot log into the storage console until we receive the permissions. Okay, permissions means login credentials. And the static pre-allocated of shared storage container. This name is logical unit number. Every LUN have a unique LUN addressing, and the data services aligned to the storage container. Okay, and the drawbacks of the traditional storage is long provisioning cycles, management complexity, over provisioning of resources, and frequent data migrations. Frequent data migration means whenever any data store is full or any of the uh, update or upgrades doing on the storage area or storage array level, we require a frequent data migrations. Okay, now let's talk about the virtual volumes. When it comes to the virtual volume, the main key concept is it's a completely application centric. Application centric means whatever the customer application required. Let's say your customer application is very mission critical application, like a SAP application. That application is required a complete RAID 1 configuration. So you can create the specific RAID 1 related profile. That profile apply to the VM. That VM will go and create on a specific storage container volume. And not only RAID 1, even the same storage container, if you want to create another VM with RAID 5, still we can create a RAID 5 profile, and using RAID 5 profile, you can create the VM on a storage container. But the same application centric options are not available in a traditional storage, because traditional storage, entire storage box configured with a only one predefined policy only. We cannot configure multiple storage policies. That is the challenge in the traditional storage. And in the vVOL, common management across heterogeneous devices. Common management is nothing but a virtual volumes you can manage from vCenter console. Similarly, you can manage from a storage console. So we can easily manage the both consoles. So that's why heterogeneous device means different types of devices. And the policy based dynamic composition of services. Correct. It's always in a storage policy based dynamic composition of services, and granular control of data services to individual VMs. But in our traditional, it's not related to individual VM. Whatever the LUN we provided, we provide the same LUN to all the VMs. But here, individual VM, you can provide a different policy, different types of strategic we can maintain, depends on the application requirement. So the benefit of vVols is here is long provisioning cycle, but here is a rapid provisioning. We use the word provisioning because it's a new storage setup. So rapid provisioning means fast provisioning, and provision as needed based on your requirement. You can provision, and efficiency through automation. Even vVols have supported for a automation also, and a simple change management. But when it comes to traditional, there is a frequent data migration, but here is a very simple change management. Now let's try to elaborate some more on the software defined storage architecture. So in our traditional storage architecture, let's observe the right side diagram. In our traditional storage architecture, we have a sandbox. Okay, we have sandbox. But if you see the diagram, the first diagram of sandbox, right side, the first diagram is, this is, let's talk about, this is a gold profile. This is a gold profile. Gold profile means it's a large virtual machine configuration profile. Entire storage box, wherever you create the VM, it's configured with a same profile only. We cannot configure the other profile here. That is a challenge in the traditional storage. This is a visual view. Earlier we discussed the theoretical. Here you can see the entire storage box. We can configure only large size VM. But when you see the other storage container, let's say here silver, it's configured with a medium range configuration. But if the same sandbox, if I want to configure a small size VM or large size VM, it's not possible, because this storage box is supported for only one specific profile only. We cannot configure multiple profiles. And the protocol you can configure as a VMFS or NFS, but only difference is, if you insert a FCSAN switch in between, you can configure VMFS. If you insert a normal network switch, you can configure as a VMFS. And VM level, the policy is only one policy for one storage box, and here also one policy for one storage box. Okay, and we can call it as LUN, logical unit number, volume based external storage in a traditional storage. Now let's talk about software defined storage. As we know, in our software defined storage, we have a two concepts, virtual SAN and virtual volumes. When comes to the virtual SAN, we already know each ESXi host have a multiple SSD and HDD. Using this disk, when you group all your disk and enable the vSAN feature in a cluster level, it will create a virtual data store. That virtual data store, we call it as a vSAN data store. But the vSAN data store also, it's supported to configure a multiple storage policy based management. So you can configure multiple policies on a vSAN, but this multiple policy option is not available in a storage box level, traditional storage box level. And the same scenario for virtual volumes. But virtual volume concept is slightly different from vSAN. In our vSAN, we configured vSAN on a local hard disk only, but in the virtual volumes, there will be, it's not supported for local hard disk. We required a real sandbox, same like traditional. But only thing is, they removed the LUN concept. We call this as a storage container. This container, you can configure multiple profiles. See here, silver color, silver profile, and this is a gold profile. This naming convention and all, any name you can maintain, just for our easy understanding. Let's say here silver color, so we call it a silver profile. This is a gold profile. But when it comes to the traditional, we cannot configure both profiles on a same storage. Okay, only the one profile only supported for one box. And the virtual volume, the main key concept is SPBM, storage policy based management, and vSphere is, you can configure VVOLs on a either ESXi host level, or you can configure on a vCenter level. Okay, the same points I mentioned highlighted here. Virtual volume simplifies operations through policy driven automation that enables more agile storage consumption for virtual machine and the dynamic adjustments. So dynamic means automatically adjust in the real time when needed. But when comes to traditional, we cannot do dynamic adjustments. Always it's a manual activities only. And key benefits. The main key benefits are simplified storage operations. So vVols allow separation of provisioning and consumption of storage for virtual machines, and reduce the delivery of service levels. Even the service levels also we can reduce, make it possible to adapt every changing application and business requirements quickly. Whatever the customer require, the specific profile you can create, and you can store the virtual machine on a specific vVol container. Okay, and improves the resource utilization, precisely mapping the application requirement which storage resources when they are needed, fundamentally eliminates over provisioning issues. But over provisioning issues still exist in the traditional storage, but that option is overcome in a virtual volume data store. Okay, now we'll talk about some more detail on what is the concept of before virtual volumes. So in before virtual volume, how we do, we already discussed about FCSAN, iSCSI in our previous session. So normally in the real-time scenario, how the team created is, VM provision is separate activity and storage provisioning is separate activity. Normally separate VM activity, VM provisioning is activities taken care by vSphere admin, storage provisioning activities, excuse me, taken care by storage admin. let's talk about the 1 to 5 points. The first point is, before we create the virtual machine, the immediate first step is predefined LUNs. So predefined LUNs means either write 5 LUN or write to 1 LUN or write 10 LUN should be configured by the storage admin. Once they configure the LUN, this is the sandbox. When they configure the LUN, they say this LUN is assigned to our ESXi host. Let's say in this diagram, this one is ESX1, ESX2. So they allows these two hosts to access this LUN. This part is taken care by storage admin. And the second item is request for volume. Our vSphere admin requests for a volume, and they will create a volume. Volume means LUN only, and using one or more LUNs. Based on our request, they can provide the LUNs, either one LUN or multiple LUNs. Once they provide the LUNs, they will assign a volume. Volume means it's a logical unit number. And finally, our vSphere administrator, they will add that LUN to the ESXi host. Once they add the LUN to ESX host, it will allows you to provision a virtual machine to volume. Okay, this is the before virtual volume concept. Now, let's observe the our vSphere virtual volumes architecture high level overview. So this is the high level overview diagram. So here, let's try to understand one by one. We'll talk about storage admin activity first, and then we'll discuss about the vSphere admin activity. And the storage admin activity is, let's say storage admin scope is until here. The complete storage network is taken care by storage admin, and the vCenter, ESXi host, these items are taken care by vSphere admin. And the storage admin, the main activity for the storage admin is they will maintain the storage container. You, based on your existing local hard drives, they will create one big storage container. Within the storage container, it's not limited to one profile. You can configure multiple profiles, like silver color one profile, and bronze color one profile, gold color one profile. There are three profiles are configured in this diagram, and this configuration is taken care by storage admin. But in our previous concept, traditional storage, FCSAN and iSCSI, this profile and this storage is configured as a LUN. That LUN is accessed through fiber channel switch only. Even in our VVOLs also, we can access through fiber channel switch only. But only thing is, there is no LUN concept, but they changed the technical name is PE. PE is nothing but a, it's like a normally when we remove the LUN concept, it requires some of the protection endpoint. This PE is nothing but a protection endpoint. It's almost similar like a LUN concept. Okay, but the benefit of protection endpoint is it will allow you to connect multiple profiles. And how we can configure protection endpoints and all, there is a separate software is needed. That software name is VP. VP means vendor provider, or we can call it as VASA provider. VASA means vSphere application program interface for storage awareness. That is a full form of VASA. I repeat, VASA means vSphere API storage awareness. API means application program interface storage awareness. This tool can be used by both storage admin or vSphere admin. So that means we no need to depend on storage admin. We can directly log into the VASA console. From the VASA console, you can configure storage container, and you can create a multiple storage profiles. That profiles you can present it to the ESXi host and vCenter server. So this can be managed by either vSphere admin can manage or storage admin also can manage. Okay, this is the high level diagram, and in the right side I mentioned about policy examples. These policy examples can be, you can configure a thin disk one profile and thick disk one profile, and performance wise if you need high performance, you can maintain one profile. And availability means continuous availability for virtual machines, you can configure one profile. So this is the examples for how to profile a how to configure a storage profile policies. Okay, and published capabilities. Even in our storage container level, whatever the storage we purchased, either a HP storage, Dell storage, IBM storage, or any third party vendor storage, normally the storage box level, we have a default features. These features include snapshot. All our virtual machines allows to create a snapshot, and we have a storage level replication facility. Replication is main purpose is whenever your primary storage is down, we can all the data replicated to secondary storage. That replicated will be always mainly for a disaster recovery purposes. So most of the storage vendors will provide the feature for replication. We can replicate from one data center to another data center storage, and the deduplication facility, and also the encryption facility. Okay, so this is the high level architecture. Whatever the components we have here, uh, this protection endpoint, VASA provider, storage container, each component I will explain in the following slides one by one. It's the same like in our previous FCSAN also we discussed about the architecture components like LUN. What is the LUN we discussed, and we discussed about fiber channel SAN addressing. Same way we are going to verify the virtual volume components. Okay. So virtual volumes architecture, high level overview. Let's talk about the right side diagram first. Suppose here I given one diagram. This is a HP storage box. We have a storage box is looks like this. Okay, this is a 3-part storage. Using the HP 3-part storage, our virtual machine directly connected to the container, and you can allows to configure a multiple storage volumes. These virtual volumes not limited to one profile. We can configure multiple storage volume profiles. Okay, so vSphere admin mainly taking care of virtual machine portion, and storage admin taking care of storage portion. Okay, and let's talk about the all the points now. VMware virtual volumes, in short form we call it as VVOLs, are new vSphere storage architecture. Okay, it's a new vSphere storage architecture that was created to replace the existing VMFS and NFS implementation. So previously we have VMFS and NFS concepts, but in the VVOL itself it's a separate data store. And we will create a unified standard and architecture for all storage vendors. So any vendor storage, it's supported by default. Okay, and the storage protocol to adhere to, and it leverages the vSphere APIs for storage awareness. In short form, we call it as VASA. Okay, VASA provider to accomplish this. In order to do the virtual volume configuration, the main software name is VASA. VASA provider. This VASA software is provided by specific storage vendor. Suppose if you buy a HP storage box, HP vendor will provide the VASA information. And suppose if you buy from EMC storage, EMC vendor will provide a VASA, how to configure the VASA appliance and all. They will provide the software appliance details. Okay, and it require a additional license. And virtual volumes enable vSphere to write virtual machine natively to storage arrays without using any kind of file system. So we no need any kind of file system like VMFS and NFS. We can directly using virtual volume, you can write the virtual machine to the storage container. That's why virtual machine directly connected to storage container. And this eliminates, so as we discussed, the main concept of virtual volume is this eliminates the LUN provisioning. So no need of LUN concept. Okay, and enable storage array to automatically reclaim. Even the reclaim means whenever your virtual machine is deleted, if you want to recover your space, that reclamation process is automatic. But in our traditional storage, the reclamation process is manual process. Okay, when virtual machines are deleted or moved to another storage, reclamation also automatic reclamation option is available using virtual volumes architecture. And virtual volumes allow storage arrows to be VM aware. So all the virtual machines aware of which volume I am storing, which volume I am going to assign. Okay, VM aware. And array features can be applied directly to individual VMs instead of entire LUNs. Okay, which provides more flexible consumption of storage resources with greater granularity for increased efficiency. So to accomplish all, so if you want to accomplish all these features, the main option is vSphere storage policy based management is used to allow policies to build based on array capabilities to be assigned to the virtual machines. Okay, so now we are going to observe the virtual volume architecture in a conceptual way. Okay, it's easy to understand the conceptual diagram. So in our conceptual diagram, let's talk about the in the detailed way. Suppose in our previous diagram, if you see in the previous diagram, I just mentioned the storage array only. But within this array, what we can do and all, I'm trying to explain in the conceptual diagram. Let's say this dotted line is explains about the storage array. So this storage array is the, you can buy the storage array depends on our customer requirement. Let's say here how many arrays we have? One storage array, second, third, 4, 5th. So 5 storage arrays connected in a one big storage box. So within this storage array, it's not limited to one storage container. Same like our LUN, we using the multiple disk, we are configuring a multiple LUNs, LUN 1, LUN 2, LUN 3, and so on. Same way, without the LUN concept, the name LUN name is, you can just forget about the LUN in the VVOLs concept. We use the terminology as storage container only. You can configure storage container 1, storage container 2, and so on. Multiple storage containers we can create. So container is nothing but it consists of all the virtual volumes. So each storage container consists of multiple virtual volume, and each virtual volume we can present it to the ESXi host. ESXi host or vCenter level. Okay, and from the storage container 2 also you can connect the multiple, you can create multiple virtual volume. These volumes presented to the vCenter server and ESXi host. But how we are connecting means, in our previous FCSAN concept, we configured using a LUN concept, but here no LUN, only virtual volume, but the connectivity process mainly taken care by protocol endpoints. In short form, we call it as PE. Okay, so main concept is protocol endpoint. This endpoint will maintain about the all the uh, data path. Okay, and as I mentioned, the vVols can configure on FCSAN, FCOE SAN, iSCSI, and NFS. Okay, still the same as our previous architecture. Only difference from vVol and FC other storage boxes, no LUN concept. That is only the simple funda. Okay, and this connectivity is same. We are aware of multiple connections we can use, either fiber channel, FCOE, iSCSI, and NFS. And now come to the vSphere environment within our data center, VMware vSphere box. So within vSphere means ESX host and virtual center. And vSphere level, this same storage container is considered as a virtual data store 1. See, they mentioned the point here is corresponding to storage container 1. And same way, storage container 2. When we presented through protocol endpoint, when we connected to vCenter level, it's presented as a virtual data store 2, but it is a corresponded to storage container 2. When we are adding in the vCenter level, the naming convention as a virtual data store, or we call it as a vVOL data store. Okay, naming convention will change when comes to the vCenter area, but in comes to the storage level, we consider as a storage container. And remember, storage container is nothing but a virtual data store only. Okay, the same point I mentioned in the right side notes, virtual data store equal to storage container. Okay, and to manage this connectivity and creating the volumes and all, how we can create is, the main intelligence is VASA API. API means application program interface. This program interface provided by VASA provider. VASA provider means this is a one of the software based appliances. This virtual appliances given by the specific storage vendor. If you buy a Hitachi storage, Hitachi vendor will provide you the VASA software. Okay, if you buy a HPE storage, HPE vendor will provide the VASA software. All the vendors have a different VASA appliances. Those appliances only we can use to configure a virtual volumes on the storage container level. Okay, so same point I explained here again. An architectural diagram provides the overview of how all components of virtual volumes functionality interact with each other, how it's connected from each other, and no need to configure LUNs. So this is the important point. No need to configure LUN or NFS share. There are four major components within our architecture. There are main four components when it comes to implementing the virtual volumes. The four components are protocol endpoint. If you see in the right diagram, here you can see the protocol endpoint. The protocol endpoint main purpose is management of access control and communications. I just mentioned the short word comms. Comms means it's a access control and communications purpose. Communication between storage array and vCenter level. And storage container, what is the use of storage container is management of data capacity. All the data disks, whatever the array have the disk, all the disk we grouped and we make it as a one container. So management of data capacity is maintained by storage container. And vendor provider, another name is VASA. VASA means vSphere API storage awareness. So this VASA is a software only. This software is management of data operations. If you want to maintain all the operations of storage array and vSphere level, you need to log into the VASA only. But how we communicate between the vCenter and the storage container is the main thing is API only, application program interface. There is a one URL. Using that URL only we can connect to the both. And virtual data store. Virtual data store means our vCenter level, we are using the terminology is data store terminology. Virtual data store is nothing but a storage container only. Okay, so the same components. Let me try to elaborate some more additional deep dive information. Okay, so virtual volume storage architecture. Just now we observed the conceptual architecture. Now let me try to show you the communication diagram. Okay, within these components. So this portion, if you see here, we have a ESXi host, vCenter server. We already know vCenter server is to manage multiple ESXi hosts. If you want to store all your virtual machine, we require a storage array. Okay, so we have the storage array to store the virtual machines, and to manage ESX host, we have vCenter server. So three components are I've written. Now let's talk about the VVOLs. One of the main architectural component is protocol endpoint. So now let's try to understand what is the use of protocol endpoint. Now protocol endpoint main purpose is it's maintain the data path. Okay, so the same data path is that point highlighted here. Logical IO input output proxy that serves as a data path between ESXi host to virtual machine and their respective V volume. So all the virtual machine respective V volume is comes under the storage array only. So this connectivity data path is taken care by protocol endpoint. Okay. Now how we can control this storage? That control is taken care by VASA provider. It's a software component only. So this VASA provider software is given by the storage vendor. This VASA provider, it will help you to control the path from ESXi host to storage array and vCenter to storage array. Same point I mentioned here. VASA provider software component means it's a virtual appliances. Same like our vCenter appliance. vCenter appliance is a management tool to manage multiple ESX hosts. This is given by the VMware. Same way, if you want to manage your storage container, our storage vendors will provide you one appliance software. That software is nothing but a VASA provider. That software component that mediate means just like a intermediate out of band management APIs communication. API means application program interface communication for virtual volume traffic between vCenter server, our vCenter server, ESXi host and storage array. All the communication established through VASA provider only, but the data path is maintained by protocol endpoints. Okay, now let's talk about the another component, that is storage container. So storage container is nothing but a pool of raw storage capacity that becomes a logical grouping of V volume. So logical grouping of virtual volume, another name in our previous concept is LUN, but in the VVOL they removed that name. They considered that as a VVOLs, seen as a virtual data store by ESX. The same logical grouping storage container, when we see on the ESX host level, we call it as virtual data store. Okay, so the same data store, we are storing the virtual machines. So if you see here, the virtual volumes, how when we create the virtual volumes, all the virtual machines are created on a vVols. Within the storage container, it's not limited to one vVol. You can create multiple virtual volumes. Okay, so virtual volume means it contains encapsulated of virtual machine files. Virtual machine files means VMX file, configuration file, disk file, and their derivatives. All the virtual machine files are stored on a each virtual volume. Okay, so now another component is storage profile. So storage profile is the main concept for vvolume. So storage profile, if you see here in our vCenter level, SPBM, storage profile based management. This purpose is set of rules that define storage requirements for virtual machine based on capabilities provided by storage array, same as vSAN. Even the same SPBM concept we discussed in the virtual SAN also. So similar concept in vVols also. Okay. So each each component, protocol endpoint and also the VASA provider, there is some additional points. I will cover the additional points in the following slide. So if you see the same virtual volume architecture, the main key point here, now we are going to talk about protocol endpoint. So let's discuss the protocol endpoint additional points. The protocol endpoint is set up by storage administrator. So obviously this is taken care by storage administrator. The protocol endpoint is part of the physical storage, that is fabric. It's treated like a LUN only. It's just treated like LUN only, but the naming convention is PE. And the PE supports typical SCSI and NFS commands. So we can use the same NFS commands and FC commands, and virtual volumes are bound and unbound to a protocol endpoint. So that means whenever you want to bound, you can make it a bound, or bound, we can also use the word bind or unbind. So ESX or vCenter server initiate the bind and unbind operation. And existing multi-pathing policies and NFS topology requirements can be applied. So can anyone tell me what is a storage level multi-pathing policies? We have a 3 multi-pathing policies.
Yes, fixed path and round robin and most recently used.
Very good. So we have the 3 multi-pathing path selection policies. These policies are fixed MRU round robin. So this policy is still applicable in our virtual volume concept. Same policies. So the same point I mentioned here. Existing multi-pathing policies and NFS topology requirements can be applied. Okay. Now we'll talk about some more points on the. So hope you understand the protocol endpoints. What is the purpose? Now we'll focus on the another component, some more additional points. Storage container. So I highlighted in the green color here, storage container. So in vCenter server, storage container are represented by virtual data store. A storage container is configured by the storage administrator. Obviously, this container portion taken care by storage administrator. And a storage container is a logical grouping of virtual volumes. So we can grouping a multiple volume, multiple disks, we can group a logical volume only. And a storage container capacity is limited only by the hardware capacity. So of course we have a, suppose we have the hardware here, multiple 5 storage arrays are available. We created a 5 storage container. If you want to add one more container, definitely we need to fill up our array. That's the reason they mention here is limited only by the hardware capacity. We must set up at least one storage container per storage system. If you have one storage array, minimum requirement is one storage array, and maximum depends on your available hard disks. You can configure multiple storage containers. Same point I've written here. We can have multiple storage containers per array, and we assign capabilities to storage containers. What is the capabilities means? Every storage box have multiple capabilities. In our, if you observe the high level architecture diagram, we discussed about each storage have some capabilities, published capabilities. All capabilities applicable for containers. Okay. Now we'll talk about the another component again, some more detail. VASA provider. If you see in our same logical conceptual diagram, VASA provider is highlighted here, VASA API and VASA provider. The purpose of VASA is mainly management component for specific array. Specific array means storage array, and presents array SPBM capabilities. SPBM means storage policy based capabilities, provides storage awareness services, create and manage virtual machines. So ESX and vCenter connect to VASA provider using VMware defined VASA protocol. So VMware by default supported for a VASA protocol, and the services can run anywhere. Interface to array is private. So this VASA logins and all, it's only dedicated to our storage environment only and vCenter environment. It cannot be a public. So that's why interface to array is private. Now we'll talk about the virtual volume. What the virtual volume objects. Okay, in our same like vSAN virtual objects, we discussed about data memory swap and all. Same concept applicable in the vSphere virtual volumes also. If you see in the right side diagram, I just took the some internet screenshots. When we create one virtual machine in the vSphere client view, you can see virtual machine consists of config file. This file also considered as a VVOL virtual volume folder only, and swap also consists of one virtual volume folder and vmemory data. So all are the, we already aware, VMX file, VMDK file, swap file, and memory file. The same points I mentioned here. There are 5 different types of virtual volumes. So all virtual volumes are config, data file, memory file swap, and other VMware vSphere solution related files. Like suppose if you are creating one template .vmtx, if you are creating a snapshot .vmsd, those files will created. All the files are considered as a virtual volumes objects. Okay. Now, how earlier today's session, before we add the LUN, we did a rescan. Similarly, even if you want to add our virtual volumes to our ESX level, there is a concept of discovery process. Same like our LUN, VMFS and NFS, we are doing a rescan storage. Same way in our virtual volumes also, the discovery is a bidirectional process. You can discover using a protocol endpoint level or storage container level. Storage container means raw device, and protocol endpoint means that is one of the feature available in a our VVOLs. One of the component is protocol endpoint. So let's talk about how we can do the bidirectional process. In our protocol endpoint level, storage administrators set up a protocol endpoint. They will set up the protocol endpoint, and ESXi host discovers the protocol endpoint during the scan. So today we observe how to do the rescan. During the rescan itself, it will identify the protocol endpoint. And vSphere API for storage awareness, VASA, is used to bind virtual volumes to the protocol endpoint. This is the one method. And another one, storage container. Even storage administrator can set up the storage container defined by capacity and capability, and VASA provider discovers the storage container and reports to the vCenter server. And virtual volumes are created in a virtual volumes data store. So whatever the folder is created, all folders technically we call it as a virtual volumes. So until now, we discussed about the all the architectural components and all, and one of the main virtual volume feature is storage policy based management. So this concept, software defined storage, main focus is SPBM only, storage policy only. So now, what type of storage policies we can create? I am trying to give some example here, but in the real time scenario, it's completely customer chosen. Sometimes customer may give different types of combination. Some customers may follow different type of combination. I'm trying to explain with one example now. Okay. So the first point is storage array advertises capabilities via VASA provider. VASA provider means the complete storage vendor appliance product. So this product will defines all the capabilities. Suppose in this diagram we have a one HPE 3-par storage. HPE 3-par storage is looks like this. Within the storage, it's not limited to predefined RAID 1. We are going to do multiple capabilities. But in the if you do not have vVols concept, we cannot configure all this in a one storage box. This is possible only with software defined appliance. So this is the intelligence. VASA provider is a software defined. This will only maintain the complete intelligence, storage level intelligence and control. Let's talk about the existing capabilities. So within the storage, what is the capabilities is we have a SSD disk, solid state drive, and the drive speed is you can provide a 15K. That means 15,000 IOPS, input output operations per second. This IOPS normally where we can set is, suppose if I log into our vCenter server, you can choose any virtual machine. Let's say I'm creating a new virtual machine. While creating the virtual machine, it's asking to choose the VM name, VM1, click on next and choose any ESXi host. I'm creating a one virtual machine here. So within this virtual machine, here only we can see the storage policy options. When I select drop down menu, you can see multiple storage policies. See, you can see management storage policy large. Large means obviously the virtual machine configuration, CPU, memory, disk and all large size. And virtual machine storage policy regular. Regular means there will be your company can maintain some standard procedure for regular and single node. That means this policy means the virtual machine always run on a one single node, and stretched means it will run on a multiple sites. It will stretch from one site to another site, and stretched light, thin, thin provisioning. These are all the default policies, and there is a vSAN default storage policy, virtual volume no requirements policy. That means without any requirements, also you can configure the VVOLs policy. Okay, this point only I'm going to explain now. There are multiple types of policies. Suppose I'm going to create one virtual machine here, and it's ESXi host. Operating system is default. We can choose. And in the customization also, when we see here, if I expand the hard disk, we can see the maximum size it's took as a 197 GB is available size, and our virtual machine size, you can choose 90 GB or any minimum size, for example 15 GB I assigned. Under the new disk, there is some additional options. You can choose virtual machine storage policy. You can choose the location where our virtual machine is going to store, and the disk provisioning. And the provisioning, you can choose either thick provisioning or you can choose thin provisioning. And the sharing, you want to share this virtual machine disk to unspecified means it by default it won't share. No sharing also no share. Multi-writer, suppose if I choose the multi-writer option, that means the same vmdk file can be shared to other virtual machine. Multi-writer means same time two virtual machine can store the data on a same hard disk. So in detail of multi-writer we'll discuss in the later session, but to try to understand, within one virtual machine hard disk there are a multiple options are available, and the shares also available. Share limit, when you see the limit here only you will find the IOPS information, input output per second. By default it is showing as unlimited. If you want to choose the custom, you can set your custom IOPS also. Minimum is 16 IOPS, maximum is this is the maximum IOPS. So this point only I'm trying to explain from the our slide. So you can set your IOPS either 15K IOPS or 7.2 IOPS. That means 7,200 IOPS or 15,000 IOPS. This limit you can set from a virtual machine disk level itself. Okay, and the disk can be either SCSI hard disk, SATA hard disk, anything you can use. It depends on our available storage container hard disk. So let's say this is the specific hard disk speed. And the second column is talking about the redundant array of inexpensive disk. Any of the RAID you can configure. For our easy understanding, I took the three examples. You can configure RAID 1, you can configure RAID 6, you can configure RAID 5. And also not only speed and RAID redundancy, we also have some additional features in our storage box level. The additional features are encrypted. Encrypted generally for security purpose. Even if anyone try to copy your VMDK file, anyone hack your VMDK file also, it's always in a encrypted format. No one cannot open the encryption until we decrypt manually. Okay, so encryption is also one of the security feature, and the replica also one of the feature. Replica means normally we can replicate our data from one storage box to another storage box. That is also one of the storage boxes capability. And QoS is nothing but a quality of service. That is also we can divide the bandwidth, to divide the bandwidth, certain bandwidth for one VM, certain bandwidth for another VM. Those and all we can use doing a QoS method. Okay, and we have a cache tier. Cache tier means it's like a primary storage. For fast temporary purpose, we'll use the cache tier. Even during our virtual SAN lab, we configured capacity tier and cache tier. So the same feature available in our storage container box also, and thin provisioning and deduplication. These are all the normal default storage box capability features. But using our storage policy based management, we can group first row. Let's say if you talk about first row, we can create one policy, second row one policy, third row one policy, or else any alternative combination randomly you can pick one feature and you can prepare one storage policy. Okay, how we can prepare storage policy, I'm trying to explain one example here. So storage policies created in vSphere and assigned array capabilities. Array capabilities means whatever features in our storage array have, all the feature capabilities also we can use in our policy. So for our easy understanding, I created three policies here. Policy 1, policy 2, policy 3. For our easy understanding, let's say policy 1 is bronze, the color is bronze color. Policy 2 is silver color, and policy 3 is gold color. Let's say normally gold means it's a costliest one, right? So in our Policy 3, if you see here, we are using a high fast provisioning SSD disk we are using, and RAID 1 means completely mirroring. Whatever the disk you create, virtual machine disk, all the disk will be duplicated. We have a mirroring concept, RAID 1. And we also have a cache disk is configured, thin disk is configured, quality of service is high. So that is considered as a policy 3. This is the example I'm giving you, but in our real-time scenario, this will be changed depends on customer scenarios. Okay. And policy 2, it's a silver profile. Let's say for our easy understanding, it's a silver profile. Even the same silver, gold, bronze also, it's explained in our previous diagram also. If you see in our previous diagram, there is a VM storage profiles. I missed to explain here. See, this is the gold profile, silver profile, bronze profile. The names and all, you can put any name. Just for our easy understanding, I took the name as a gold, silver, bronze. Okay. And even the cost wise, gold cost is high, silver is medium range cost, bronze cost is less cost. Okay. So based on our cost only, our profile also should be prepared. So our gold profile have all the additional capabilities, and the silver profile have a less than SSD, 15K IOPS, RAID 6, encryption is available, replica available, deduplication available. I prepared as a policy 2. And now policy 1. Now the features are reduced in policy 1. We have only 7.2K IOPS, RAID 5, thin and replica. Only these features are available. And next step is when we create the profile, what we can do is let's try to understand the third point. VMs assigned a storage policy based on the requirements and SLA. SLA means service level agreement. So even just now we observed virtual, while creation of virtual machine, we have an option to choose the storage policy. You can choose the storage policy depends on our current requirement. Even every virtual machine, you can maintain different policies. Okay. So for our easy understanding, I try to explain the three examples. Policy 1, policy 2, policy 3. See, policy 3 applied for these 4 VMs, policy 2 applied for these 4 VMs, and policy 1 applied for 3 VMs, these 4 VMs. Okay. Now the fourth step is SPBM provision VM on a appropriated storage as defined by policy and maintains compliance. So here see gold container, silver container, and bronze container. Whatever the once we created that, all the virtual machines where it will store. Suppose if I choose a policy one, all VMs comes and store on a bronze profile only. And policy 2 VMs, it's a silver profile. So all the VMs comes, it's a store on a silver data store. And even the gold VMs, all the gold VMs comes and store in a gold data store. But it cannot be mixed on a one data store. Okay, we have a different storage container. Clear? This is about the storage policy based management concept. Now, let's talk about the data store creation. So until now, we discussed about our virtual volumes architecture and individual architectural components. What is the virtual volume objects and storage policy based management. Now, how we can create a data store creation. So data store creation will quickly log into our vCenter. Just now we observe if you want to create a data store, how we can create, select our cluster, go to the data store tab, and here select the actions. You can choose storage, new data store. But before going to choose the new data store, always recommend that first we have to do the rescan. So rescan will help you for scan for new VMFS volume, similarly scan for new storage devices. Suppose for virtual volume, if I connected a new storage device, new storage array, that array will detect using the VASA provider as well as it will detect using a protection endpoints. So the recommendation always is first we have to do the rescan. Once the rescan is completed, again go to the actions, storage, new data store, and then you can choose the virtual volume. When you select the virtual volume, see, create virtual volume data store on storage container connected to the storage provider. So storage provider means our VASA provider virtual appliances. Okay, when just click on next, when you click on next, it will ask you to provide the information. But by default, if you really connected to the virtual storage container, it will detect automatically after rescan. But in our home lab, we do not have a real backing storage container device. That's the reason it is showing as no items found. Okay. So let me cancel here and we'll talk about what is the requirements for data store creation. Even if you see the high level diagram in the right side, in our previous vSAN, we used only local hard disk, but in our virtual volume, you can enable virtual volume on a sandbox or you can enable on a NAS box. Anything you can enable, but how it will communicate is using the API calls only. Virtual volumes will communicate. And this entire pan, we call it as a data plane. And the control plane is nothing but our vSphere plane. Within the vSphere plane only, we can configure a storage profile. This storage profile will also use your container capability features. Okay, and once we create this control plane, we can create a data store. After creation of virtual data store, we can create a multiple profile VMs like Oracle gold profile, SQL silver profile, and normal test machine bronze profile, and SAP. SAP means it's a production VM only, production ERP application. For ERP application, always go for a high configuration like gold profile, and Exchange. It's one of the mail server. For mail server, we'll go for a medium range configuration. So this is the example I'm trying to show here. Now, let's understand the description. A vendor provider is a storage provider based on vSphere API for storage awareness that allows the array to export its capabilities and present them to vSphere. Okay, it will present them to the vSphere, and the protocol endpoint is a replacement for traditional LAN. So this is the important point. It's replaced the traditional LAN. The only new terminology is protocol endpoint. Okay, and can be accessed with the typical NFS or SCSI commands, and virtual volume data stores are created on the protocol endpoint. Virtual volumes are objects only. What is the virtual volume objects means? It's a VMX file, VMDK, NVRAM, and swap files. Okay, and the creation method is, so this is the 3 steps. The first step is register the storage provider in vCenter server level. So register the storage provider. How we can register is, let's log into our vCenter server. If you go to the our vCenter home shortcuts, and here look for a storage profile. We have a storage profile here. Okay, here also you can configure a multiple storage profile. See, there is a virtual volume no requirement policy. Even if you want to do any modification for this profile also, we can do modifications here. Okay, and any modification adding new policy also, you can click create and create a storage profile policies. Now for adding the VASA provider, go to the administrator. Let me recall the storage administrator option where we can add. Go to the client plugin. See, when we see the client plugin here, you can see default plugins are added here. VMware Cloud Provider Management plugin and vCenter Lifecycle Manager, VROps, vSAN plugin, and also Lifecycle Manager plugin. Similarly, even if you want to add our vCenter any of the additional extensions or any of thing, we can normally use, we can add that additional solutions from a storage option. Okay. This is system configuration, customer improvement program. Okay. Normally, this is the option here only we can add the plugins when we have a real VASA provider. Let me look for any other options are available here. See, when we select the vCenter top actions, there is not much options are available. When we select the data center, there is some additional features. Now, when I select the data store, we'll see the any additional options. Increase data store capacity. We can place the maintenance mode for data store and configure store IO control. Also, we can configure delete data store all volumes. Okay. And go to the configure. Under configuration, see the space reclamation options are available here. Let me look for a API adding procedure. This is multi-pathing, hardware acceleration. Okay. Capability sets. Even container also we can configure. Okay. In our next lab, I will show you how we can add the VASA IP. Normally, the first option is using the plugins only. We can register a storage provider in vCenter server. That is the first step. And second step, discover the protocol endpoint. Any protocol you can use, either iSCSI, NFS, FC, and so on. And finally, we can create a virtual volume data store. Okay. Now, we'll also observe what is the major changes from traditional storage to VVOL in our protocol perspective. Let's say how vVols transform storage in vSphere. Normally in our VMFS, we are aware what is a VMFS LUNs and all, and virtual volume is completely a no LUN concept. It's a VM centric. Okay, that is the first point. In VMFS, we consider as a LUN centric, siloed storage pools and array services aligned to LUNs. When comes to the virtual volume, it's a VM centric only. Okay, no silo storage pools, array services aligned to virtual machines. Now come to the another point. It's a static. In our VMFS level, it's a pre-allocated storage over provisioned resources. But in our virtual volumes, the benefit is dynamically allocated storage using only what is needed. Okay. And as I said in our earlier challenges, VMFS is one of the complicated management using vendor specific tools. But in our virtual volume is a simplified management using vSphere interfaces. And comes to the deployment. Deployment is like a time consuming, longer provisioning, manual space reclamation. Provisioning is always longer and even reclamation is always a manual space reclamation. But when it comes to virtual volume, it's a instant provisioning. It's a very fast provisioning and automatic space reclamation. Okay, this is the complete how the differences in VMFS level and VVOL virtual volumes level. Now we'll talk about the protocols also now. See what changes between the file and block protocols with virtual volumes. We know the storage types are file level storage, block level, and object storage. Let's compare the file and block level. We already know in our file and block level, the storage adapter is we can use iSCSI initiator or HBA card, but in our NFS level, NFS client only. And input output transport is network or we can use fabric. Fabric means fiber channel switches. In our network attached storage, we use normal network only, IP based network. And host presented as LANs. And in our NFS, we call it as mount point, file system VMFS. Here is NFS. Storage VMDK files, VMDK files. And the storage visibility also here data store level only we can visible, but we cannot see the LUN information from our vSphere level. But even in the NFS storage, we can see only VM level. Now let's observe when we go for a virtual volumes, what is the change is happening is in our host level, we can see the naming convention changed to storage container, and even in the NFS file storage also naming convention is storage container. When it comes to the file system name is vSphere native. vSphere native means virtual volume is a vSphere default natural storage type method only. The type method is vVOL. It's a vSphere native means it's a vVOL. Okay, and the disks where the virtual machine store is it's stored on a virtual volumes. And the data store also completely a VM level data store. Everything we can control on a VM level using virtual machine storage policies. Okay, so this is the complete vSphere virtual volume concept. Now we are going to talk about the vSphere storage real-time scenarios. So before we start the real-time scenarios, shall we take the short break or can I continue? Can we take the 10 minutes break?
Yes, sir.
Okay, okay, we'll take the 10 minutes break and after the break, we'll continue the real-time scenarios because real-time scenario also very important. It will be useful for all the storage concepts. Okay, now, we'll take the 15 minutes break. Okay, after 15 minutes, we can start. Thank you.